video tutorial on how to make a graph. First of all, why do we graph? Well, scientists create graphs to display two types of data. We've got your bar graph here and your line graph. Now let's have a look at a bar graph first. Bar graphs are used to make comparisons between measurements that are separate. When we go back, we can see that this is about what kind of pets do you own? Rabbits, dogs, cats, goldfish, hamsters. We can see the number of people who own each one there. Now, the amount of rabbits you own isn't necessarily going to directly affect the amount of dogs that you own or the amount of cats you own. So that's why we use a bar graph. Just comparing different types of data, different types of animals. Line graphs are used to show relationships between measurements. Measurements that relate will affect each other in a recognizable pattern. So here we have our line graph. We're looking at how seeds grow over a period of 6 days. You can see on the 0 day, before they started growing, they had a height of 0. Look, they've got some nice units there, which is excellent to see. Going up about 1 centimetre per day, roughly. Not exactly, but roughly. Let's have a look at the different parts of a graph now. First of all, your graph needs to have an overall title, and that goes up the top. Now, there's two types of axes, and you're going to need to remember throughout your entire high school for science and maths as well, what's the x-axis, what's the y-axis or axes. Now, the x-axis is the horizontal one, and horizontal means straight, like a horizon. It's kind of straight and flat. Look at the horizon, it's always flat. That's how you remember. Now, you always need a title for your x-axis with units. Notice in this graph, I actually haven't done that there. Now, the y-axis is the vertical one that goes to the sky. Sometimes people say, Y to the sky. That's how they remember it. Now, you need a title with units. They've got their units there, minutes, but they don't have a title, so it's not so good there, actually. Another way I remember the difference between X and Y is that the Y, a capital letter Y, actually has at the bottom a vertical component. It's got a vertical bit in it. So that's how I remember the difference between Y and X. Next, you've got your trend lines. Now, you don't have to have more than one, but you can have as many as look comfortable. So they're actually looking at the average running speeds of boys versus girls. Boys are in black, girls are in red. For our graphs, we're only going to need one trend line, but you can put more in if you need to. Now, extra hints. Always put the independent variable on the x-axis and the dependent variable on the y-axis. Remember, the independent variable is the one that you choose to change, just that one by itself to make it a fair test. That one's the one that goes on the x-axis, the horizontal axis, and the dependent, the one that you measure, always on the y. It just looks better that way. Always graph your averages, never your trials. Graphs usually start at 0. So you'll see in the paper, newspaper, magazines, sometimes they start their graphs like 100 and they go up in hundreds after that. But the best graphs usually start at 0. Now, you need a minimum of 3 data points to show a relationship. If you've only got 2, then no point doing a graph. For our experiments, we actually have 3, and that's 3 different size canopies, and with each of those canopy sizes comes 3 different averages for the time that it takes to drop. So let's have a look. Here we go. Area of canopy versus average time taken to hit the ground. Now, I've filled in these other values here. They're just random. You're going to actually have to calculate it. But the first area of the canopy, we had a 12 centimeter by a 12 centimeter. Now, what's the area of 12 centimeters by 12 centimeters? Well, 12 times 12 is 144. Centimeters by centimeters is what we call centimeters squared. So that's 144. And you can see up here, at the top there, I've put the centimeters squared. See how the 2 is slightly small? That means squared. You can access that when you're writing by making it a superscript. Maybe have a Google search if you're not sure how to change the writing to superscript. Now, the average time taken for a parachute to hit the ground. Let's say for this one, for the 144 centimeters squared, it was 1.12 seconds. Now for the 250, remember I've made that up, you're going to have to change that to what it actually was 1.59, and I had one of 360, and that was 2.6. Alright, time to graph. So, charts, line graph. We're wanting to use a line graph now because the data relates to each other. You see when I do that, it doesn't look so good right now. I only want one line, and On the x-axis, no, on the y-axis, I want my dependent variable, which is the seconds, and on my x-axis, I want the area of the canopy. So I'm going to have to change this dramatically. Select the data. So category of the x-axis, the horizontal axis. I'm going to press this little button here, and on the horizontal axis, I want the area of the canopy. So I'm going to highlight the 3 different areas there, and click the button again, and you can see that this might be a little bit small for you, but it has changed. Second, I've got 2 series. I don't want 2 series. Remove one of them. Good. I only got 1 trend line now, 1 series of data. Now the y values, I don't want those y values there. I want the y values of the time it takes to hit the ground. So I'm going to highlight those, and boom. Good. So far, so good. I'm going to click on that little series one. You can include it, but you don't have to. I just deleted it. Next thing you're going to have to do is to create some titles. So the title above the chart there is going to be our overall title. And I always like to do the y-axis versus the x-axis. So on our y-axis, that was the average time it took to hit the grounds. I'm just going to highlight it here because it's easier for me. Oop. Versus the x-axis, and that is the area of canopy. Good. Now I'm going to make my whole thing bigger so I can fit it in, and fix up my spelling mistake. Good. So, done that. I need to now insert my x and y axes labels. So axes titles, I'm going to put one for the y, one for the x, or the other way around. Okay, so this was the area of canopy. Oh, area of canopy, remember that was centimeters squared, and this was the time taken for parachute to hit the ground. That was in seconds. So you're done. But for those of you who have Windows PCs at home, it's exactly the same thing, but I'll just show you the slight differences between the 2 programs. This is a perfect graph for the Mac side of it. So let's go over here. This is on the Windows side of my computer now. I'm going to highlight that same data again, and I'm going to then press insert, same thing again, this graph here. It's done exactly the same mistakes, but you'll notice when I right click and then push on select data, it looks slightly differently. It looks slightly different. So axis range for the x-axis, I wanted that to be the area of the canopy there. I'll fix that up there. Okay, I only want 1 series, so I'm going to click remove. And the y-axis is actually what I want it to be. So that's pretty good. If you need to edit that, you can click edit and then select the data that you want your y-axis to be. Same thing goes again. You can delete that if you like. Highlight the whole graph, click on layout, and then you can add your titles like I did before. I won't waste time though. So there you go. All about graphs for your assignment. Hope you